Hey everybody, today we are going to solve problem 304, range sum queries immutable and LeetCode. So in this problem, we are given a 2D matrix of integers like the one that you can see here. And we should implement the initialize function for this class as well as the sum region function. So the sum region, the inputs are two values, the top left and bottom right corner of a. So in each query, we are given a top left and bottom right corners of a square or rectangle, and we are supposed to return the sum of the values that all cells that reside inside that given rectangle. So in these type of questions, that means the matrix itself is not going to change over the iteration, but instead we are developing a sort of API for the given matrix. Lots of queries will be called. So for a unique matrix, the sum region will be called with different corners. The row 1 call 1, row 2 and call 2 corners. So one way, so the straightforward for each row 1, so we can store the matrix in the class, and then for each row 1 and call row 1 call 1 and row 2 call 2, we just iterate, implement it in a 2 for loops, just store it in a sum value and then return it the sum. But this is not effective because, as I said, since this function is going to be called again and again lots of times, so probably we will be having a time error. So what is the more efficient way to implement this? So let's say this is our matrix. If we define a new matrix or sum matrix or SM, for example, that for each cell, for each I and j, we just store the sum of the values from that cell to 0 and 0. So assume that instead of storing the matrix itself, since we know this is the type of the query we are gonna ask, then for each cell, we ignore row 1 and call 1, so and just put 0 and 0 here. And for each ij, we just store the sum of all values. So for example, for the bottom right cell here, we just store the sum of the whole matrix. So this cell will have the sum of all cells in the matrix. So let me clean up everything. What happens is that, so we just do it, we compute the SM, the sum matrix in O and M, considering that the size of the matrix is m by n. We just iterating through the cells only once and then compute the sum by having a dynamic programming. How can we obtain that? We can by knowing that it is already previously computed. So for each iteration, for each I and j that we want to store the sum, instead of iterating through from 0 and 0 to I and j and sum of all values, we know that I and j minus 1 store the sum for this portion. So this portion is already calculated and stored in this cell. And also, if I change the color, for I minus 1 and j for this cell, the sum values for this portion is already stored. So in order to put the sum value for this new cell, what we can do is to just using dynamic programming, sum these two cells, like this, plus this one, the value on the left and on top, plus the value of the self itself. So if it's x plus x, minus, if you take a look here, so this portion is being added to the sum twice. So by just subtracting that square part on top left, so by I minus 1 and j minus 1, we can easily compute the new value for some of all values in the matrix from 0 and 0 to I and j in this new cell. So let me just we are going to implement the init function first now. So after that, we can discuss how we can compute the sum region by knowing the top left and bottom right corners faster by having this data structure in our class. So before going into the implementation, so we are going to loop through. One way is that when you're looping through, just check what happens for the edge cases. So we discussed that for each cell, for ij, we need 3 values, like I minus 1 and j, I and j minus 1, and I minus 1, j minus 1. By knowing the value, previously calculated values for these cells, we can compute the value for I and j. But for the edges, like the left and top or the top left corner itself of the matrix, we can implement that by having a couple of if items, if checks to make sure that we are not going beyond the matrix. But one easier way is that if we pad the matrix with zeros, like instead of m by n, I create a new m plus 1 and n plus 1 and just put zeros. So these zeros are just padding, so without having any specific reason to have or being effective in the values, since we are storing zeros, we just make sure that we are shifting the whole matrix one down and one to the right, so that whenever we are iterating through the ij's, we know that we are not going beyond the memory limit. So there must exist some cells, but the values are 0, but it doesn't matter in our case. So let's say first of all, m and n equal to length of the matrix and the length of matrix 0, and our S matrix or sum matrix equals, we first put everything at 0 times n plus 1 for range m plus 1. So this is our new, and after that self.sm, for example, equals sum matrix. So this is our initialize, and we are looping through for I in range m, for j in range n, then sum matrix of I plus 1 and j plus 1, because we added a pad to the matrix. So we are at this iteration, we are finalizing the value for I plus 1 and j plus 1 by knowing the sum matrix I, j, and I plus 1 and j, I and j plus 1 and I and j. So is equal to, first of all, the current value. So for each, so we know that using this portion, we are adding this portion first and adding this portion, removing this portion since it is being added twice, and adding the value itself. So it's equal to, first of all, the matrix I and j plus, so we are using this sum matrix triple times. So let me add that first here. But instead, so we are adding I and j plus 1, I plus 1 and j, subtracting, we are removing the duplicate calculation, and that's it. Okay, so now we have our matrix. So what happens, let me rename this row 1 column for simplicity, so we can say I0 and J0 equals to row 1 and col 1, I1 and J1 equal to row 2 and col 2. So we have, for every iteration, since we have already stored the sum matrix as we discussed into the class, for that, let's say we are given an I0 and J0, I0 and J0, and I1 and J1. And we know for H1, we can easily, in O1, directly access to the sum of the matrix from the top left corner of the whole matrix to that index. So to compute the sum inside this rectangle, we can first consider this one and then subtract this outside, anything outside this rectangle should be removed, right? So we first remove this top left. So this is equal to this one first, I1, J1, the sum matrix of I1 and J1, minus the sum matrix of I0, J0. So we just remove this portion, and then also removing this portion and this corner and this corner. So it will be this rectangle and this rectangle. But as you take a look again, this top left portion is being removed twice. So one time, initially we remove that, and then by the left and top rectangles, we are removing that twice. So it is being removed 3 times. But we need to add that back. So it will be, so instead of removing that, we can just ignore that. Remove these top and left rectangles, and then add that back to the sum. So we can say our answer is, or simply return that, we're going to return that self.sm of I1 plus 1. Remember, the plus 1 is because we, for simplicity in our for loop, we added a padding, a 0 pad. We extended the dimension of our matrix by 1 on each dimension. So, and j plus 1 minus self.sm. So let me repeat that, and then we fix the. So first subtract the top, I1, I0 minus J0, so I forgot to put 1 here. This is the bottom right, and J1, J0 plus, so we are adding that back because it was removed twice. So I0 and J0 was removed twice. And simply by that, I hope that worked, yeah. That was everything. So we could successfully running that by storing the sum of the values for each, using DP here in this problem, instead of storing the matrix itself and looping through the for each query. So in O1, we can, this initializing the matrix is OMN, n times n. We are just doing that once, but after that, for some of the region, for every query, we're just returning in O1. The answers are faster. So hope you enjoyed it. That was everything for today's problem.